At this point, we all know that matter consists of atoms. You have read it in high school, and you all kind of have an idea that there is atoms which are at the basic block of material. But this atomic theory that all matter is composed of atoms, it grew out of three observations which ultimately became laws. Law of conservation of mass, law of definite proportions, and law of multiple proportions. And for the purpose of this course, we will go through them briefly. In a chemical reaction, matter is neither created nor destroyed. So what does that mean? So when chemical reaction occurs, total mass of the substance involved in the reaction does not change. So how does that work? What does that mean? So if we take a simple reaction, carbon plus oxygen, carbon dioxide. Again, I'm just taking a hypothetical, very simple reaction. There's a lot more to this, but just so you all understand. So this is 12.01 mass. This is 32, and I'll tell you where these numbers are coming from. Okay, and the mass of this carbon dioxide is, and I should probably write it like this, the mass of carbon dioxide is 44.01. Okay, so if you come across an equation that looks like this, iron plus oxygen leads to iron oxide, this is a little bit funny because there's one iron here, two oxygens here, and there's two ions here and three oxygens. So where does this other ion come from? And where does this third oxygen, where does that come from? Okay, that's one question. Okay, so obviously you cannot create another iron atom. You obviously cannot create an oxygen atom, right? It needs to be produced in a reaction. So that's where the concept of balancing the reaction came from. So really, we cannot add another iron atom from nowhere. You cannot create another atom from nowhere. So then, probably this reaction started as 4 iron atoms combining with 3 oxygen molecules to yield 2 iron oxide, right? So 4 ions, mass of 4 ions together, mass of 3 oxygens, mass of 4 ions, and mass of 3 oxygens. Okay, so this is where balancing comes into picture, because mass of reactants before the reaction should be equal to mass of products after the reaction. Now, all samples of a given compound, regardless of their source or how they are prepared, have same proportions of their constituent elements. Okay. It's also called as law of constant composition. Okay, for example, water has water's H2O, correct? 16 grams of oxygen and roughly 2.0 grams of hydrogen. Okay, so mass ratio of oxygen to hydrogen is 8 to 1. Okay, and this could be water from anywhere, regardless of the source. You take water from GSU campus, you take water from home or dorms or anywhere. Water has a constant proportion, 8 parts of oxygen to 1 of hydrogen. So there's, regardless of the source or how it was prepared, they have same proportions of their constituent elements. Water always has 8 to 1 oxygen to hydrogen ratio. Law of definite proportions is also, like I mentioned before, also known as law of constant composition. So when two elements, call them A and B, from two different compounds, the masses of element B that combines with 1 gram of A can be expressed as a ratio of small whole numbers. Okay, what does that mean? Say, take the example of carbon monoxide and carbon dioxide. Okay, the mass ratio of oxygen to carbon in carbon dioxide, oxygen to carbon in carbon dioxide is roughly 2.67 to 1. Okay, which means 2.67 grams of oxygen reacts with 1 gram of carbon. In carbon monoxide, the mass ratio of oxygen to carbon is 1.33 to 1. Okay. Now, so carbon monoxide and carbon dioxide, they both have same elements, carbon, oxygen, right? They have carbon and oxygen. So in this case, it was 1.33 to 1, and in this case, it was 2.67 to 1. Okay, so the ratio of mass of oxygen in carbon dioxide to carbon monoxide is 2, and this is the simple ratio that we were talking about in the previous slide. So the carbon monoxide and carbon dioxide, if you compare the ratios, when two elements form two different compounds, right? Two elements, carbon monoxide, they form two different compounds. The masses of element B that combines with 1 gram of A. So in this case, B is oxygen and A is carbon. Okay, so the masses of B that combine with 1 gram of A, they can be expressed as a ratio of small whole numbers. So 2.67 to 1.63 is a small whole number, and that is what is known as the law of multiple proportions.